Today I want to talk about what someone said about me on the internet. Here it is.
The majority of people think you're a liar, Matthew, based on what you've done here. I would agree. I just see you as a scumbag, fraud, shyster liar who's out to deceive 500,000 people with his views. That's what you're here to do, deceive. Because you're scum. And I'm not afraid to say it, based on what you've done here.
Wow, okay. Now why on earth would someone say that about me? I'm not a shyster liar trying to deceive people. Well, before I get into that, let me first say hello. Yes, it's been a while since I posted my last video, and since then, I've visited Arches National Park in Utah right after it snowed, which was beautiful. I visited Santa Barbara twice, went to Tucson for Christmas and Thanksgiving. My car turned over 100,000 miles. I filmed part of an online course, and I started teaching an intro to computer science class, and maybe I'll talk about all that in a future video. Meanwhile, I've finally gotten stirred up enough. I've been prodded enough to make a new video. Why? What happened? Well, Nathan Oakley, a flat earther, featured this video of mine on his online show earlier this month. I heard about it, and then a few days later, I joined his online show and talked about it some more with him there. So I wanted to make some kind of response video. Both of his show episodes are more than an hour long, so I can't reply to everything, but I did want to respond to a few things. Let's start with this quote right here.
Yeah, it's just fraud, just scummy fraud, shyster behaviour from a scammer. Just a scammer lying to his audience with numbers, trying to convince them that clock hands move slower than 1,000 miles an hour. No, just a scummy, fraudulent liar. That's what you are, Matthew. Yeah?
Who, me? No. Okay, now wait a minute. What in the world is he talking about? I need to back up some and explain. In my original video, I explained how flat earthers frequently say that just because we can't feel the earth rotating, that means it's not actually rotating. Here's my response to that idea in my original video. Next, flat earthers say we don't feel rotation, and they're correct. But that's because Earth is rotating so slowly, at a rate of 0.000696 RPM. Yes, that translates to more than 1,000 miles per hour at the equator, but remember, we humans cannot sense speed. We can only feel acceleration and rotation. And the other rotations around the sun and around the galactic core are even less of a factor. Do you think a tiny ant standing on the hour hand of a clock would notice it moving? That hour hand is rotating at twice the rate compared to the daily rotation of the Earth. And then when Nathan played that part of my video on his show, here's what he said. Twice the rate compared to the daily rotation of the Earth.
Oh, really? You think that the outside edge of a clock goes at 2,000 miles per hour?
No, that's not what I think.
Wow, you really are stupid.
No, I am not.
You see, when you talk about edge velocity, that's the speed.
Right, and that's why I was careful to say rate and not speed.
The ant would be going on the outside edge of the hand. What you've done is you've convoluted the RPM with the rim velocity.
You mean conflated, but no, I understand that they're different.
Now, the outside edge of a clock hand, just because you can describe it with a very low RPM and say it's faster than the RPM of Earth, doesn't alter the fact that on the outside edge of Earth, you'd be travelling at 1,000 miles an hour.
Right, I'm not disputing that.
And that is definitely not the speed that an ant would be travelling on the outside edge of a hand.
I agree, and I suppose I could have been more clear about that. That's true.
You're just a con man. Like a shyster, a liar, a scumbag?
No, I am none of those things.
No, it's a little magic trick that you've just had with your audience, because you've just told them that an ant on the outside edge of a hand is going slower than 1,000 miles an hour, and 1,000 miles an hour is actually very slow.
No, the rotation RPM is very slow, not the speed.
That makes you stupid, like dumb.
No, again, I am neither stupid nor dumb.
An idiot. No, the outside edge of a clock hand isn't going faster than 1,000 miles an hour and definitely isn't twice the rim velocity that we don't feel.
That's because we don't feel velocity. In my original video, I only spent 35 seconds talking about this, so I suppose I didn't explain it as carefully as I could have. And Nathan's right that the raw speeds aren't comparable at all. When I went on his show a few days later, I said this.
I will start by saying that I think you were right to point out the thing about the different rates of rotation versus speed. I think that I should have been more clear in my video to describe the difference, RPMs versus speed at the equator versus an ant on a clock and all that type of thing. if I were to redo it, I would try to expand that section to explain it a little bit better.
I see. When you expand upon it,
Only that one part?
would you consider giving us perhaps the measurement of the R value that the assertion for a sphere Earth rotating would be based on?
I'll answer his question about the R value in a bit. Also, saying that I could have explained it better is not a concession that I was wrong or that the Earth is flat. So let me explain all of this in more detail to be really clear. When something is rotating, there are three relevant numbers. The RPM measures the rate of rotation, how many times it rotates in a given amount of time, RPM, rotations per minute. You can also determine the speed and acceleration of something on the outside edge of that rotating object. Those two numbers depend on the radius from the center. Now, the Earth rotates at about 0.0006963 RPM, and relative to the center axis of Earth, something on the equator is moving at 1,040 miles per hour or 1,674 kilometers per hour. And that circular motion requires an acceleration of 0.033916 meters per second squared. So those are the three numbers for Earth. Let's compare that to a clock. The hour hand of an analog clock rotates at a rate of 0.0013889 RPM, almost twice Earth's rotational rate. Not the speed, the rotational rate. An ant standing on the end of a 6-inch hour hand would be moving at 0.00006958 miles per hour or 0.00007979 kilometers per hour. And that circular motion requires a tiny acceleration of just 0.000000003224 meters per second. Okay, so why did I make this analogy? It's because for both the ant and the person on the equator, both the RPM and the acceleration are very slow. The hour hand rotates at an RPM rate almost twice as large as the RPM rate of the Earth. As for the acceleration, yes, the acceleration of the Earth at the equator is 10 million times larger, but even at 0.034 meters per second squared, it's still a low number. It's these small numbers that matter, not the raw speed, because human beings cannot directly sense raw speed. We can sense rotation and acceleration, but not speed. I know it seems like we can sense speed. After all, we all know the difference between riding in a car going 20 versus going 60. But we're not directly sensing the speed. It's the sound, the vibration, and our eyes that tell us how fast we're going. That's why I showed this video of a coin on a Japanese bullet train. If the train ride is smooth enough to not knock over the coin, we also won't feel the acceleration. Here's another example. Imagine waking up on a commercial jet airplane in the middle of the night where you can't see out the windows. You hear the engines running, but you can't see how fast you're going. And since you cannot directly sense speed, you don't know whether the plane is going 600 or 200 or taxiing on the ground or even stopped at the end of the runway. That's because human beings do not sense speed. Okay, so that was a big long explanation. Let's listen to a bit more.
No, just a scummy, fraudulent liar. That's what you are, Matthew. Yeah? By the way, make sure you go to Matthew's channel, like I would expect in return when he covers this video, if he covers it, or if anybody who we cover covers us in response. I'd hope that he would share my link, and with the same encouragement that I've given my audience, let Matthew know. Tell him Nathan Oakley 1980 and crew responded to your wonderful video. Yeah, the one where you're a shyster, fraudster, scammer, liar with your numbers about angular velocity versus rim velocity. I mean, that just seems like a scummy, underhanded, scammy tactic. You know, from your typical bull-believing wanker who will lie to your face. Like this man, the liar known as Matthew Weathers. That's you, my friend, you wrinkly old scumbag.
Okay, well, I will share his links. They're below in the description. In case you want to hear more of the same, you can find many, many hours of similar rhetoric there. Let's go back to his question from before. Where does the R value come from? Now, when flat earthers ask that question, they're asking about the radius, the R value of the Earth. Flat earthers say that neither the radius nor the curvature of Earth has ever been measured. They're right. Neither of those have been directly measured. In other words, you can't slap a ruler on Earth's radius or put a huge straight edge on the curvature of the Earth. Instead, Earth's radius and curvature have been indirectly calculated based on other measurements. But so what? The same is true of the height of Mount Everest. It's technically never been directly measured. Instead, it's been calculated using surveying techniques with measured angles, and more recently by timing GPS signals. But no one has ever directly measured the height of Mount Everest by putting a ruler on its side to see its altitude. But using indirect calculations, that doesn't bother me. I think that's perfectly reasonable. Similarly, we cannot directly measure Earth's radius, but we can calculate it. Eratosthenes, an ancient Greek, is said to have been the first to calculate the size of the Earth with sticks and shadows, as told by Carl Sagan in the original Cosmos series. It is true that this observation is also consistent with a flat Earth and close local sun, but Eratosthenes assumed that the Earth is spherical and that the sun is very far away in order to do his calculation. So to be clear, there are two questions here. Question 1, is the Earth a globe? And then question 2, if it is a globe, what's its radius? Flat earthers complain that this is a begging the question fallacy. And it would indeed be circular reasoning if you were trying to prove the Earth is a globe by finding the radius, like this. Assume the Earth is a globe, we can calculate a radius, therefore this proves Earth is a globe. No, that's a logical fallacy. However, that's not what Eratosthenes was doing. He wasn't trying to prove that the Earth is a globe. He was just calculating its size, its radius. So it's not a fallacy. It is true that you have to assume that the Earth is a globe before you calculate the radius, but that only makes sense, right? I mean, it doesn't make any sense to try to calculate a radius unless you think there is a radius. If the Earth is a globe, then we can calculate the radius. That's not a fallacy. But that's the so-called flaw in logic that Nathan is talking about in this next clip.
I will berate you for your use of logical fallacy to lie to children when you educate them about the sphere belief that you have based on flaws in logic. Now, I don't see it as reasonable to lie to children about your assumptions based on flaws in logic. Now, that's not reasonable. Do you understand my disdain for you and my justification for calling you scum when you justified lying to children based on a flaw in logic?
Yes, I understand your disdain if that's what you think I'm doing.
Of course, I am also against lying to children. I'm against using flaws in logic. And in fact, I want to teach students how to recognize logical fallacies. However, I'm not lying or using a logical fallacy when I teach students how Eratosthenes calculated Earth's radius.
No, you are doing that. You have just told me how you assume Earth is a sphere because that's the only way you can justify measuring its radius. That is a flaw in logic called begging the question. That's not what I think you're doing, it's what you factually are doing, and it's your justification for lying to students about Earth being a sphere. Now, that is why I have a high level of disdain for teachers in this arena, like conspiracy cats. Because he knows better. We've told you it's a flaw in logic. You've conceded it's a flaw in logic. So it is not a reasonable justification to tell students Earth's a sphere. Comprende?
Sí, comprendo. I understand. Okay, you see what I mean. There's not much more to say about that. Next, we talk at length about celestial navigation. For most of that, we were kind of talking past each other because there are two different ways of thinking about it. Two ways of calculating your position depending on whether you think the Earth is a sphere or if it's flat. Now, both ways start the same. You start by finding a star in the sky and then using a nautical almanac to determine its GP at that moment, or its geographic position, which is the point on Earth that is directly under that star. In other words, from that position on Earth, the angle elevation to the star is exactly 90 degrees directly overhead. Okay. Then you measure the angle of elevation of that star from your position and do some calculations to determine your distance from that GP. Now, which calculation you use will depend on whether you say the Earth is a sphere or if it's flat. For celestial navigation in the northern hemisphere, Polaris, or the North Star, is a pretty important star because it's always almost directly over the North Pole, so you can easily determine your distance from the North Pole and therefore your latitude. Okay, so how do you do that? And that's where the difference between the two systems comes in. If you assume that the Earth is a globe, that elevation angle tells you how much the ground at your location is tilted compared to the ground at the GP, and you can use that to determine how far away you are from the GP. That is how far you are away around the sphere you are from that ground position. Now this assumes the Earth is a sphere and assumes that the star is infinitely far away and that the light coming from the star is parallel everywhere on Earth. Now because the Earth is a sphere, each degree of difference in any direction is 60 nautical miles away from the GP. In fact, that's the origin of the nautical mile. For example, if a star is 45 degrees down from the zenith, that is 1/8 of the whole circle. So you are 1/8 of the way around the circumference of Earth compared to the GP of the star, 2,700 nautical miles. So that's one way to do it. And this calculation does not use right triangles. Now, if you do celestial navigation on a flat Earth, you end up with something like this diagram with the right triangle. Nathan was arguing that because this triangle has a flat baseline on a right angle, therefore the ground must also be flat. Here's a part of that conversation.
Do you know what a triangle is? Try and picture that.
Yes.
Do you know what a 90-degree triangle is, Matthew?
Yes, I'm picturing
Imagine
a
the
90-degree
flat bit
triangle
that
now.
meets the 90. Imagine the straight line going up being the zenith, and then the 90-degree being the baseline that meets it along the ground to your position. Do you know about that triangle? This isn't really that complicated, Matthew. Do you understand that if you've got a zenith that's plumb to the ground, that's the ground position, and it's 90 degrees to the baseline ipso facto is flat?
Okay, so no, just because the triangle you use has a flat baseline doesn't mean that the surface of the Earth is actually flat. At this point in the conversation, I finally understood that he was talking about a triangle like this, and I posted this image in the chat, but I'm not sure he saw it.
Fifth attempt with a university-grade mathematician being dragged around by a drama student.
Okay, so yes, 46
Sorry, do you want to say it louder?
in the chat.
Sorry, yes, it is a flat baseline that we will be navigating.
Yes, it is a flat base.
Earth is flat then, Matthew. Then the Earth is flat.
Okay, so
It's a flat Earth.
I'm picturing what I posted in
Sorry,
the chat.
you
Is
just
that what
need to
you're talking
concede like the last guy. The baseline we will be travelling along and are navigating is functionally and mathematically flat, isn't it, Matthew?
about? Oh, yeah, sure.
And here's the part where I want to take it back. Thinking about it more carefully, no, I wouldn't now say that navigation is actually mathematically flat and functionally flat. But here's what I ended up saying.
Yeah, sure.
So
Yeah, functionally,
Earth, that
mathematically,
would be the
it's
Earth.
perfectly flat.
That would be the Earth that we will be navigating is flat, isn't it, Matthew?
Yeah, we're navigating on the Earth, and functionally it's flat, and we navigate along a flat map, of course.
Welcome to Flat Earth, Matthew. That's correct. From a university-grade mathematician, for all of you ladies and gentlemen, that will be trimmed out and posted everywhere. That's a university-grade mathematician telling you, the audience, that Earth is functionally measured and navigated flat. Welcome to Flat Earth.
Of course, that's why all maps are flat. Like,
Of course.
I mean, the
Of course.
3D, except for 3D maps.
Okay, so I want to be clear. Although we do use flat maps and can navigate with flat maps, that doesn't mean that the Earth is actually flat. Yes, the baseline of a right triangle is completely flat, but celestial navigation on a globe doesn't even use right triangles. Yes, you can project small portions of the globe onto flat maps and use those maps to navigate, but that does not mean the Earth is flat. Here's the kind of flat Earth navigation Nathan was talking about with the right triangle. This is from John's Globebusters site. The trigonometry shown here is accurate. However, if you're going to try to find the distance from you to the GP of the star using simple trigonometry and the tangent function, you would need to know the height of the star, the elevation or the distance between the GP and the star. Or I guess you could do it with the hypotenuse and the cosine function using your distance to the star. But nautical almanacs don't have that star distance information. Why not? Well, because it's not used. Also, using right triangles would mean that the rule of 60 nautical miles per degree wouldn't work, since the tangent and cosine functions are not linear. So it's not clear to me that celestial navigation could even in principle work on a flat Earth. We can project parts of the globe onto a flat map, but when it comes to celestial navigation, the distances to GPs can only be correctly calculated assuming the Earth is a globe. You cannot do celestial navigation on a flat Earth with right triangles unless you know the distance to the star. So no, I'm not conceding that the Earth is flat just because we use flat maps. And yes, I know I didn't say things very well in that live chat, and I wish I could say things differently now. Although we do use flat maps, projections of the globe, I was incorrect to say that functionally and mathematically it's perfectly flat. I'd say it like this now. Celestial navigation works by assuming the Earth is a globe, but you can still use flat map projections of the globe, which are close enough on a smaller scale. Of course, things only got worse in the conversation once he felt like he had extracted a concession out of me. So here's some more.
Well, we've already gone through the angle about, 7 times? You know, I had a little gloat about how I'm a student of drama, like trained as an actor. And it took 6 attempts for me to get you to concede that you're not going to get a right angle out of a curve. But you're now going back to what you've calculated out of the surface of the angle that you measured was curved. That's utterly absurd. We've already compromised, as just been pointed out by QE.
I didn't concede, but you didn't compromise.
I don't know what you're doing.
I'm trying to explain what I'm telling the kids.
Yeah, I hate you. Yeah, I hate you. You're the reason I homeschool. You're the reason I homeschool my kids, because I don't want people like you to teach my kids. As you chuckle about this. Shut up! Shut up! Stupid man. Telling my audience why I homeschool. Because you, when pointed out and compromised 6 or 8 times, laugh about it. That's why I hate you. And I wouldn't put my kids in front of you.
Do you think your kids are going to end up as...
I am not going to put my kids in front of you, you lying scum.
Okay, so at this point, the conversation had fully devolved. And don't worry, I don't take it personally. I know he's expressing hatred for the idea that people would intentionally lie to his kids or to kids in general. And I actually agree with him. I don't like that either. Of course, I don't think I'm doing that, and he does, but that's why I don't take it personally.
So what matters, I don't care about your opinion thereafter. It's a fact. Not something you can question or query. That's a fact. It's my justification why I wouldn't let my kids anywhere near you. Because you'll lie to them. And when somebody points out how you've lied to them, you chuckle. You think it's amusing. That's why I hate you. Hate cats. Hate all of the people in this arena who know better that have been told, like you've been told, about how wrong they are and how they're using logical fallacies. And at the end of the process, you laugh. You disgust me, teacher. You should be sacked, and you can shut your mouth while I berate you.
Okay, so he said that I needed to shut my mouth while he was still berating me, and I shouldn't have interrupted him while he was in the middle of that. And also, I shouldn't have said that I was laughing at his anger. So laughing at someone is not helpful, and I shouldn't have even mentioned his kids. So sorry about that.
You disgust me, and I do believe you should be fired. The very fact that you've come here, have you taken down your video with the incorrect information that you conceded here when you joined? Have you taken that down?
No, and
Scum! Fire him!
But basically, I didn't really say anything more after that. Near the end of the show, he talked a bit about YouTube bias. So here's what he said about that.
Bearing in mind, YouTube land, we are the ones getting suppressed. We are the ones that are shoved to the bottom of the list. We've corrected him, the mathematician who's teaching your kids. He's conceded how wrong he was when he got here. It was the first thing he did. Has he taken down his video? No. Of course he hasn't. Well, that's what I demand as the suppressed YouTuber who doesn't get the views. The ones that he's got from the wrong video he put up. Well, now I'm demanding he takes it down and commends me for correcting him. Yes, so I do actually get some promotion when I correct these idiot mathematicians who teach our kids.
And actually, he's right that YouTube has intentionally been demoting flat Earth content on their platform. Finally, at the end, he did thank me for being on the show, which was kind of a nice gesture.
The people who have come and had the education from us, we've told them as advanced heliocentric understanders that they're wrong. And in this instance, Matthew's come on the show and told us how wrong he was. He's conceded. So at that point, I've got nothing but disdain for him. If he's going to say, well, I still think it's a sphere and I'm going to tell the kids anyway. Well, then you're going to get every bit of thunder that I can possibly muster. But with that, I'm going to say, first and foremost, obviously a huge, massive, enormous thank you to Matthew for tolerating my disdain and having the to do it. Props to you, Matthew. On the other hand, from a YouTube perspective, I've got a lot of admiration for the courage that you actually had to come on here and actually face our criticisms and debate with us. So thank you very much indeed.
Okay, so that was my experience of the Nathan Oakley Flat Earth Debate Show. It was quite an experience, almost like a rite of passage or something. I will also say thanks to Nathan for covering my video and for talking to me on his show. It was definitely a learning experience, let's put it that way. I do have some more clips from other people, from other shows and things, but I think this video is long enough, so I'll leave that for another time, maybe. And don't worry, I haven't changed my mind. I still believe the Earth is a sphere, and I still say that it's irrational to say that the Earth is flat. Okay, until next time, I'll see you later.